Hi class, I graded some early entries to your quiz and I wanted to clarify a few things. When you're testing for symmetry, you're plugging in some values according to the test given in the textbook, and then you are going to be simplifying it and comparing it to the original equation. And I saw some things wrong, so I want to make sure that we understand this. For the equation that I have here, we would substitute negative y. So make sure that you substitute a negative y everywhere you see a y, and then you want to simplify it. So that means 3x squared, that's still negative 5y squared. That becomes positive 7y and 6. And then you want to compare this to our original. So it's the same here, it's the same there, it's the same there, but this is different than our original statement. And because it's different, therefore we're going to say no x-axis symmetry. And I think this is the part that a lot of people got wrong. They plugged it in, but they didn't really know how to compare it. And when it's different, they didn't know what to do with that. So you make sure if you see a difference, like I said, do you see the difference from this part to this part, and the rest of it can't simplify to become that, then it's not symmetric. We'll continue to solve for y-axis symmetry by plugging in negative x. 3 negative x squared minus 5 y squared minus 7y is equal to 6. And when I simplify this, the negative x squared becomes a positive x squared because of the nature of negatives when you square them. And then you're going to compare our equation to the original. And if you compare it, each piece, when you compare it, each piece matches the one above. So that's great. So it does have that symmetry. And then plugging in both negative x and negative y, we get um, 3x squared. This stays negative, but that becomes positive. And so it's the same in most of the places. Once again, it's not same here. So you're going to say no symmetry at the origin. You have to make sure to test each part of your equation against the original equation and see where those differences lie, or if it's exactly the same. But perhaps our understanding is a little bit more, or misunderstandings I should say, it comes from somewhere else. I see a lot of people also saying, oh, when I take x plus 5 the whole thing squared and I plug in negative x, this is what I get. And that is not correct. You cannot plug it in that way. So I am going to leave that there and say don't do this. That is incorrect. You don't want to do it that way. You want to say, hey, I'm going to take this and plug in negative x here and do something like that. And then you actually don't need that parentheses there. But how do I simplify something like this? You cannot take that and say negative x squared plus 5 squared. You have to say that is negative x plus 5 and negative x plus 5 and do that multiplication. Okay? If you do that, you should get negative x squared minus 5x plus 25. And that becomes positive x squared minus 10x plus 25. Compare that to if you had the original and you want to multiply it out, you get x squared plus 10x plus 25. And the question is, when I plugged in the negative x, is this the same values as that? And so you want to ask yourself, are those equal? If they are equal, then you have that symmetry. If they're not equal, then they do not have that symmetry. And that's the part where everyone seems to be making a mistake. The third piece of mistake that I'm seeing a lot is that we're having trouble with simplifying our radicals. So if I ask you what is radical 24, I don't want you to pull out your calculator and give me some decimal approximation, say it's 4.8 or something like that, 4.9. What I want you to do is say radical 24 is the same as radical of 4 times 6. Because 4 is a perfect square, I can take that out and say, oh, that's going to be 2 radical 6. All your radicals need to be put in radical form, no decimal approximations. Alright, so I have 3 radicals here to practice simplifying. What you want to do is look for a perfect square within it, and so for this one I can see that there's a 9, that's a perfect square in it, which would become 3, but also the 8 can break down into a 4, which is a perfect square. So I'm actually going to write this one more time, and I'm going to say radical 9, radical 4, and then radical 2. And so the radical 9 becomes 3, radical 4 becomes 2, you have radical 2, so you have 6 radical 2. That is the proper way to simplify that radical. This one, I noticed that there's a 25 in radical 75, so I get 25 times 3, so I get 5 radical 3. And this last one, I have 98, 49 goes into that, 2 times, so that simplifies to become 7 radical 2. This is what it means to simplify a radical, not to use your calculator. You can't leave it whole and you can't use your calculator. You just want to break it down. And if you find a square but then you leave an extra square in there, you do need to say, oh look, that 8 can break down into more. I'm going to break it down into 4 times 2 because 4 is a perfect square as well. So those are the mistakes I keep on seeing on this quiz. Hopefully you can take that and make your quiz better.